Alright, so this is my measurement system, and it is composed of an Arduino Mega unit, and it is wired to these buttons here as inputs. We have a motor right here which is controlled by this motor driver, and it is getting power from this power supply here. This is a variable voltage regulator. It is set at 12 volts because this motor is operating on DC 12 volts. And over here on the screen here, we have the code that runs the motor when there are user inputs on the buttons. So what happens is this green button here will move this plastic piece in this direction along this shaft. It's a threaded shaft. This yellow button will move it in the other direction. And these buttons are to toggle between speeds. This is high speed, medium speed, low speed. Okay. All right, so at the beginning of each measurement, this plastic piece here, the rightmost face is going to be positioned flush against the inner face of the right side of the shaft. So this is the reference point, and the program, what it does is as we step the motor like this, if I pull this up here on the serial monitor, you can see that it is counting step positions. And that is the unit of measurement for the system. And the calibration equation is what converts that into a distance in millimeters. So I'm going to now demonstrate the measurement of the dimensions of this Lego block. Alright, so I'm going to measure the length of the Lego block. I'm going to move this out. It's on the highest speed setting, and I'm going to pull up the serial monitor. Okay. High speed setting. You can see the position is counting up. I'll just let this go for a little bit. Now we're going to position this block in here, and we're going to step it back. Let's go a bit further. So it should, there we go. And now we're going to go until it is snug. We can see we're at 1289 steps right now. So put it on low speed and we're stepping back. And we're going to go until it is clamped in there, or until the plastic housing just contacts. All right, that's in there. You can see it's sitting there, stuck in there. So if I pull it out, and that is for the length dimension.
Keep going.
So now I'm going to measure the dimensions of the width of the Lego block. I'm going to step this out again. All right, I'll put this in here, and now we're gonna tighten it back up. It's decrementing back down. And same thing as before, we're going to go until it contacts the block, or until it, yeah, as you can see about right here, it's contacting. So that gives us our step count for our width. Okay, So, as we see here, these are the true dimensions of the Lego brick, 32 millimeters by 16 millimeters, and the measured step values, which we just determined, 1261 and 627 for length and width respectively. Now, if we sub these values into the calibration equation, shown right here, where S is the step length and L is the length in millimeters, we actually get out these measured distances here, 31.96 millimeters for length and 15.92 millimeters for width. And if you compare them to our true dimensions, this is a deviation of 0.04 millimeters for length and 0.08 millimeters for width. Going back to our deviation plot, we see that our maximum uncertainty is 0.11 millimeters and negative 0.08 millimeters. Hence, the measurement system is operating within the maximum uncertainty range as required.